In this video, we will look at creating networks from polylines in Möbius Modeller. Networks can be defined using multiple polylines. However, care must be taken to create proper connections between different polyline edges. A connection requires polyline vertices to be welded. The example shows a grid of polylines. Each polyline has multiple vertices, but these vertices do not coincide with the points where the polylines intersect one another. As a result, this grid of polylines cannot form a network. It is just a set of isolated polylines with no connectivity. Here we look at a simple example of just two polylines. In this case, we can see that there is a vertex at the point of intersection. However, we cannot see if there is one vertex or two vertices. And if there are two vertices, we cannot see if they are welded. When working with networks, it would be useful to have a way of being able to visualize the connectivity. In order to visualize connectivity, we can generate some temporary lines. This can be used as a verification that the network is properly connected. The connectivity could be visualized in various ways, for example A as a circle or a box. In this case, we generate a set of lines in a pyramid shape. They looking like a series of vertical spikes. The spike algorithm looks at all positions in the network. For positions with more than two edges, spike lines are generated. For the outgoing edges, the lines reach a higher apex. For incoming edges, a lower apex. This allows us to look at the intersection and understand the connectivity between the edges. In this case, we can see that all four edges are connected. There are two incoming edges and two outgoing edges. Now that we have a way of visualizing connectivity, let's have a look at how we can create proper connections. One way of creating connectivity is to fuse positions that are close together. The modify.Fuse function can be used to fuse positions. The function will replace positions that are close together with new positions. In the diagram, positions 0, 1, and 2 will get replaced with a new position. Position 3 will not get replaced, since it is further away than the specified tolerance distance. Before the fuse, each vertex had its own position. After the fuse, the three positions are all replaced by one new position, which means that the three vertices all share the same position. If positions 0, 1 and 2 are used in some polylines, then fusing will create a connection between those polylines. Here is an example where fusing can be used. A grid is generated by creating polylines in two directions. The polylines have been created so that their vertices are exactly aligned. However, since they do not share positions, they are not connected. Fusing with a small tolerance will ensure that all vertices become welded. In this case, the tolerance is set to 1 meter. Visualizing connections reveals that the proper connections have been created at all positions. The top image shows connectivity before fusing positions. There are no spikes visible, which means that the polylines are disconnected. The bottom image shows connectivity after fusing. Now we can see that at each intersection, a spike with 4 lines has been generated. However, fusing only works when positions are close together. In this example, another grid of polylines has been generated, but this time the positions have been randomized a bit, so that they no longer align exactly. When the positions are fused, only some of the positions will get replaced. Visualizing connections reveals that proper connections have only been created as some of the intersections. One additional thing to note about fusing is that it can be a destructive operation that deletes geometric entities. In the example, we fuse the positions on a polygon. Since one of the edges is shorter than the tolerance, the edge will collapse into a single position. This will result in the edge being deleted. If the whole polygon is smaller than the tolerance, then the whole polygon will collapse into a single position. This will result in the polygon being deleted. For this reason, fusing is usually performed with a very small tolerance. Next, we will look at stitching, another way of creating connectivity between polylines. When there are no vertices at the point of intersection, fusing cannot be used. In such a case, new vertices have to be inserted into both polylines. This is what the poly2d.stitch function does. In the example, we can see the two polylines before and after stitching. Visualization of connectivity reveals that the new vertices are welded. In this example, we generate a set of polylines and stitch them in a single operation. The function will find all intersections between all edges, and will insert new welded vertices at these points of intersection.